So, welcome to this tutorial on how to create an infinite procedural generated terrain. So, this tutorial will be a little bit longer than my previous ones because there's a lot that goes into making this terrain. But anyways, let's get started. So, first off, we need to have some sort of first-person camera to move around in the world. So let's just create a quick first-person camera. So hit custom node, let's choose kinematic body, rename it to player. We give it a spatial node. We rename this spatial node to rotation helper, and we add a camera as a child to that spatial node. We give the player a script and we hit create. Okay, so the fastest and easiest way is just to navigate yourself to this URL, scroll down and copy this script here to get a first person script and paste it in. Alright, so we have to modify this script a little bit. So first off, we will remove the jumping. We'll also remove the gravity for the player. And we will make the camera to not be inverted by just multiplying on line 85 here by -1. And the last thing we need to do is to declare these input variables as well. Let's go under project, product settings, input map. Okay, so let's just hit movement forward, movement backward, movement left, and movement right. And just assign keys to this as well. We don't need collision, but we can add it anyways. Just create a capsule shape and just rotate it by 90 on the x-axis for now. And we save this scene. Alright, so we'll have to implement a chunk system in the game. So for this to work, we have to create a scene that represents each chunk in the game. So we start off by creating a spatial node. We rename this spatial node to chunk, and we can save it by pressing Ctrl S. And we attach a script to this chunk, to this spatial node, sorry. And we can remove all the comments. So I'll just increase this editor. Alright, so first off, we need to declare some variables. We need a mesh instance to represent our terrain on the chunk. And we need a noise. We need an X variable, we need a Z variable, and we need a chunk size as well. We also need some sort of constructor that takes in some parameters, and this is done using the init function. It takes in the noise, the X, the Z, and the chunk size. And that sets the variables as well. We also need to give this a class name of chunk. Alright, so each time we create a chunk, we need to pass these parameters as to the constructor. So the noise map will be an open simplex noise that Godot provides us. The X and Z value is where on the noise map that this chunk will retrieve its data, and chunk size is just the size of the chunk. Alright, so we'll override the ready function and we create a method called generate chunk. Okay, so let's just give it some extra space. Alright, so that is it for on how to generate a chunk. So I've already done a tutorial on this one, so I won't go through the code here, alright? But anyways, that is it for the chunk, so we can save this and we can minimize the script editor and we can close that as well. Alright, so now we'll have to create a new special node and we can rename it to world. We can instantiate our player here as well. We can attach a script to the world. We increase this editor again. So first off, the world has to have a reference to a noise map. So we'll override the ready function and we'll set the noise to a new open simplex noise. We just call randomize, and we also set the seed to random value. We just set the octaves and period as well. To some values. So these are the values as well that you modify, depending on what you want the terrain to look like. We will also have to declare some constants here. Alright, so we also need a dictionary to keep track of all the chunks that we have in the game. And we also need another dictionary called unready chunks. And you'll see later on why this one is used. This is because we will deal with threads. And we also create a variable to represent the thread. We can actually initialize the thread right over here. Alright, first off we need to create a function to add a chunk to the game. So add chunk. And we need to give this some parameters on where to add the chunk. And that is represented by the X and the Z value. So each chunk in the game will have a unique position. So the key to the chunks, to the chunk dictionary, will be represented by the position. So let's just create the key. This is done using the position that is divided by a comma. So if chunks, first we have to see if the chunks already exist in the dictionary, has key, we'll return. We won't add anything, okay? Else, if not thread is active, we'll have to start the thread, okay? Load chunk, and we'll have to pass some arguments to the method that we will be creating. So we have to pass the thread, we'll have to pass the X and the Z value as well. So now we have to set the unready chunks with the key to, let's say, 1. And this is just so we won't create several threads that sets the same, that creates chunks on the same position in the game over and over, okay? This is just because we are dealing with threads, we have to do this. So let's create this load chunk function that takes an array. Before I forget, we also need to check whether this key is in the unready chunks as well. Oh, sorry. Has key will return. Okay. So in the load chunk function, we will retrieve the variables that we passed as array. So first off, we pass the thread, and this is in the index 0, and then we have the value x, and it's on the index 1, and then we have the set value index 2, right? And now we will create the chunk and generate it. So var chunk is equals to chunk dot new, and as you remembered, we need to pass some parameters to the chunk. So we'll pass the noise, we'll pass the x value, we'll pass the z value, and also pass the chunk size. Okay? But don't forget to multiply this, or rather, we could actually do it in the chunk. Let me think about it. It doesn't matter. We have to multiply it by chunk size as well. And we set the translation of the chunk, translation to a new vector 3. We'll set it to the x times chunk size, 0 on the y-axis, and z times chunk size as well. Alright, so when we add a chunk, we first check if if the chunk already exists in the in chunks, or if it's in the unready chunks, which means that it's going to exist because it's on another thread and being created right now. And if it's existing in either of these dictionaries, we'll just return. We won't add anything. Else, we will see if the thread is not active at the moment, so it's not working on another chunk. If it's not, let's start the thread, call the load chunk function with these parameters. And so this is just an array with different parameters, with different values in it. And we set the unready chunk with the given key to 1. So in the load chunk, we just retrieve all the variables and the thread, and we generate the chunk, and we set the chunk's position. And when we're done with creating the chunk, we call deferred load done. So that is a function we will be creating, and we pass in the chunk and the thread as parameter. So we'll create this one, func load done with the chunk and thread as parameters. Okay, so when all this logic has been calculated, we will then add the chunk to the scene, and then we have to add the chunk to the chunks dictionary as well. So first off, we need the key, and we can retrieve the key from the chunk's x and z position. So we just add it to the chunks and then we need to erase it from the unready chunks. And then we need to wait for the thread to finish. So this also makes sure that the thread is not active. So when we have created a chunk and we have added it to the scene and everything, we can go ahead and move on to the next chunk in the game. All right. So that is it for the adding of chunks in the game. We need to create one more method, get chunk, by a given position, and by the position we can also get the key. So first off we have to check if it exists in the dictionary, so chunks.hasKey. Then if it has it, then we return it. Else we just return null. Alright, so we can save it as well, so hit Ctrl S and save it. So now for the process method. And this is where everything happens, okay? We'll create a function called update chunks. We'll create a method function called cleanup chunks. Also create a function called reset chunks. Alright, so for update chunks, first we need to retrieve where the player is in the world. So that is done by player.translation. So, anyways, we'll add the chunk. And remember, if the chunk already exists, it'll just return. It won't add anything, okay? What is wrong? Did I? Yeah, chunk amount, okay, oh, sorry. We should actually be able to try and run it now. Let's see if it's possible. So we'll select the world, and there it is. Okay, so first off, I want to head into the world, and I want to increase the position of the Y position of the player, and try it again. Let's head into the player, into the camera, and just increase the far by, we max it out now. Okay, so we went a little bit too high with the player, so let's just lower it again. Well, let's say also, let's say 200, okay? And as you can see, we get a terrain. But we are not done here. So let's get back to the world script and maximize this. Okay. So as you can see, we have two more methods over here. So if we just leave it as it is for now, as you can see, when we move the player now, okay, let's just increase the player's move speed as well. So in the player's move script, max speed just times 10, let's say times 10. Okay, so if you move the player now, as you can see, the terrain updates, and that's perfect and all, but where we came from, it should not be visible anymore, okay? Because otherwise we will run out of memory pretty fast if we just keep on expanding the terrain. So that we have to fix, and it's pretty easy. This is not a perfect system that I've created, but it works. So first off, we need to create a new variable in the chunk. We'll name it should remove. It could be true as default actually. So in the world script, we need to first, when we are doing all the logic for the chunks, we will have to get the chunk on position X and Z, and we have to check first if the chunk not equal null, so it exists. We set the chunk to should remove to false. Okay, we set the chunks to should remove because it's within our vision and it should not be removed from the game. So in the cleanup chunks, we will do some cleanup. So for key in chunks, we'll iterate through each chunk in the chunks dictionary, and we retrieve it from the chunks by the key, and if the chunk should remove, then we remove it. So chunk dot q free, and we also need to erase it from the dictionary as well. And this just means that if this variable is true, then it should be removed. And all chunks that is not in our vision of the player or within this for loop should be true. And this is what this function is for. So for key in chunks key should remove equals true. All right, so let's just try it out to see if it works. So we generate the first square and then we move a little bit, and we see the chunks update, and they also get removed from where we came from. And this is awesome. Okay, so just to make the terrain look a little bit nicer, in our world, let's just create a temporary mesh instance and just give it a spatial material and hit this little arrow over here and convert to shader material, and we save this one as well. Save as terrain.material. Okay, and we can remove this mesh instance again. So the terrain material now contains all the properties that a spatial material does. First we need to create two uniform variables. That represent our sand color and our grass color. We also need to create a varying flat out color. We create a function called lerp color, and we just set the out color based on the Y position, and we lerp between the two colors that is represented from the sand color and the grass color. So I think there you have it. Okay. So we create two uniform variables. We create the out color. We create a function that lerps between two colors, and we set the out color to and we calculate the out color based on the Y position of the vertex. So once again, this is something that I've already talked about in my previous tutorial on how to create a random generated terrain. So if you're interested, go check it out. I won't explain anything further on this one. Just one last thing is to change the albedo over here to out color, and that is it. In the chunks, the chunk scene, we head over to the script and we just attach the material to this one. So plain mesh material equals, let's zoom in a little bit so you can see. Plain mesh material equals load terrain material, bam, and we preload this as well. Alright, so let's save and hit run and see if it works. And as you can see, we get a nice, awesome, cool looking terrain. There is so now we have some sand and some grass on it. Final touch, we can create a function called generate water, and we create a simple water. Can actually just create a plain mesh. We don't even need to subdivide it. We do need to create a material for the water, so let's do that. Right click on the rest folder, hit new resources, spatial material, create a new one. Oh, we do not override that one, but we save it as water. And in the albedo, first in the flags we set transparent to true, and in the albedo we change the color to a bluish color, and we lower the alpha channel a little bit, something like that. And we then set it to water.material, and we add this to this plain mesh as well. Okay, so I think that is all we have to do. We can try it out and see if it works. It do not work. It do not work. Why doesn't it work? Ah, sorry. We need to create a mesh instance. Mesh instance equals mesh instance dot new mesh instance dot mesh equals plain mesh, and then we just set it. We add the mesh instance as a child, and now we have some simple water as well. Alright, so that is it, guys. Peace out.